Hi folks, welcome to Reliable and Blameless, Learning from SRE, part of our ongoing series on modern DevOps practices. Today I want to take y'all through some of the foundations of SRE and how to create a culture of reliability and blameless operation. My name is Sandip and I'm a DevRel engineer focused on helping teams adopt better DevOps strategies. I've been with Google Cloud for about 7 years, minus a little time away, helping teams of all shapes and sizes adopt and optimize for cloud. You can always find me at CRCSMNKY, that's Circus Monkey, on Twitter if you've got questions or comments about DevOps or Google Cloud, or just to say hi. Now, we've talked about the 4 key metrics as trailing indicators of software delivery performance in past episodes. Well, if we embrace a reliability culture and practices, how does that help us deliver software faster? The most obvious impact is felt in a more indirect way through a reduction in the number of failures we ship per change. Now, it might not seem clear at first, but think about it like this. If we understand how our software works and how to keep it reliable, we develop a better understanding of how to identify and mitigate errors. And if we incorporate those learnings into our CI and test processes, we can learn how to better spot failures before we ship them to prod, which has the effect of reducing that change fail rate over time. And while the 4 keys are trailing indicators of software delivery performance, how do we know if we're on the right track? Well, the DORA research provides a series of indicators that tell us if we're on the right track. When we're talking about reliability, the indicators that come to mind typically involve measurement and some aspect of process. Now, if we can start incorporating these measurement and reporting capabilities, then we can start to see improvements in the software delivery process. First and foremost, we need to have monitoring and observability tools built right into our software systems. And those tools need to be used to inform the business of how our software is doing. We also need to incorporate proactive failure notifications and build our systems to give us a sense for when failures will happen, not just after the fact. And teams need to have a culture of working in process limits. That means allowing us to prioritize and limiting our focus to a smaller number of really high priority tasks. And finally, we want to have a consistent and easily approachable set of management capabilities so that we can start to generate a common language and a common understanding across all of the business. And all of this is the core part of the SRE philosophy. So let's talk a little about SRE just to get us started. Google started out by running a pretty large amount of global infrastructure. But with all that infrastructure, we needed new ways to manage the monitoring and observability data being generated. So we added more infrastructure just for that. Well, as you can imagine, that led to additional complexity. More machines running applications meant we needed more machines to help with observability. And you can see how that would lead to a lot of complexity over time through extensive use of automation. And then we realized we needed to stop what we were doing because we were looking at a lot of noise and not really understanding how our systems were impacting our end users. So we actually started from a different approach entirely. Instead of worrying about the machines, we wanted to worry about how our software affects users. So we wanted to take a sort of user-centric approach to understanding our software reliability. And that meant kind of modeling things from the perspective of the user and modeling the problem from the perspective of the user. And what that led us to is sort of the first kind of most important principle around reliability, which is it's the most important feature of basically any software system. It doesn't matter how many cool features your software has. It doesn't matter if it works consistently or not. If it's not working well, if they can't depend on it, users won't be happy and you'll lose that business. But getting to a very high state of reliability has a cost, both an engineering cost and a resource cost, whether it's infrastructure or humans. And you have to remember with reliability, it isn't an all or nothing game. Right? Software isn't perfect, and trying to strive for sort of 100% reliability and uptime, it's not really going to work. So we have to start thinking about how reliable does our service have to be, or our set of services? And that also sort of means taking on the question of how much risk are we willing to accept within our software as well. Now, reliability goals, as you're trying to think through and determine them, they really have a whole bunch of kind of additional bits of context we need to understand. So we have to ask ourselves things like, well, does this service have any downstream or upstream dependencies? Is the service going to be paid or free? How does reliability impact revenue, right? We need to manage and account for that as well. And we should also look at what the competitive landscape looks like. What are our competition doing in terms of offering reliability or reliability guarantees? And as we were starting to think through all these challenges, we needed to understand, again, how should we measure reliability and then communicate that to our end users? And the second really kind of core principle around SRE is that our monitoring doesn't decide reliability, right? Our users do. It's a difficult concept to measure around, but the best place to start is with the user-facing metrics. So let's explore exactly how we measure those things. Now, measuring reliability, I think often folks will sort of think about, well, we need to measure our software and monitor that. So let's use our normal software and infrastructure metrics. But it turns out these are actually bad indicators of what the user feels. For example, things like CPU, ping response time, disk cache latency, those do have an impact on the software. But these aren't the ways in which users evaluate our software. Our service-specific metrics aren't really user-focused right out of the box, and they don't map to that user's overall experience. So when it comes to setting goals around reliability, it's helpful to start with your users and the experience you want them to have, and then work your way backwards. So again, metrics like CPU and disk and all that sorts of things, like those are important for us to understand as we're trying to manage our infrastructure and monitor things. But as far as determining reliability, those aren't the places to start. Now, it turns out after a lot of work, what we did understand is that measuring reliability from an end user's perspective really comes down to how the software feels, and right, how available is it? So we wanted to, again, take that user-centric view of it. And so we started looking at things like latency, right? Request and response latency has, again, a big impact on that user feeling of responsiveness. Availability, right? If the software is not even up or available, or if it's erroring out pretty regularly, that's also going to have a negative end user experience. And then to a secondary degree, we also want to monitor and kind of manage around things like throughput, right? Is the system fast or slow, which sort of plays into latency as well. And saturation, right? How much sort of bandwidth and availability can we jam through the system? And these are all the things that end users feel when they interact with our software. And so we started developing a whole bunch of these pillars. And where we started was around three main areas: SLIs, SLOs, and SLAs. SLIs are service level indicators, SLOs are service level objectives, and SLAs are service level agreements. Now, if we kind of dive in a little bit further, what that really means is SLIs are the metrics that matter, the ones that we care about, right? Things like latency and availability. And the objectives are the goals that we're trying to strive for. What are the goals we want to have around latency and availability, right? Do we want to set particular per service targets? Do we want to set ones for the overall system? And then the last one, service level agreements, it's basically the promise we're making to our end users and how we're going to make it right if we violate those objectives or those SLOs. When you're starting to think about what an SLI means, we start to kind of represent that as a ratio, right? It's the number of good events over the number of all possible events or valid events, and then we just multiply that by 100, and that gives us our percentage or our understanding of that SLI, that indicator. And then when we want to turn that into an SLO and sort of up-level it into a goal, right? An SLI, or that metric, we set a target for that, and then we set a measurement window. And that relationship of all three of those facets is really what becomes the service level objective. Now, when you're setting SLOs, it's easy again to think that you want to strive for, maximum or 100% or the most we can get. But really, you actually want to find that really, really thin dividing line between where my customers are happy and unhappy. And that's right where you want to set your SLO. You want to set it such that if it's barely met, if you just barely eke out that SLO and you achieve that objective, your customers are happy. And if you were to just miss it, your customers are going to be unhappy. And that's really the right way to do it. Now, again, that's not an exact science. It's different for every piece of software. But think back to a few slides ago when I talked about how do we determine what we should set our SLOs for? What should we set those goals or objectives? Do we have dependencies? Is it tied to revenue, right? Those are the sorts of things you have to keep in mind. And when you're trying, again, to determine what your SLOs are, some of the best practices that we've used in the past are, obviously avoiding perfection and absolutes, right? You don't want to try to strive for 100% reliability or 100%, objectives every single time, because those, frankly, are really hard to meet, and they put a lot of pressure on engineering teams. You also want to have as few SLOs as possible. You're not setting one for every single service. You want to find the most impactful services, the ones that you can measure that your users feel, right? So if you were running a big e-commerce application, you may not want to set an SLO for every single service in that e-commerce stack. You may want to set an SLO around things like maybe the front page or the home page, and maybe the checkout process, or maybe the invoicing and the cart process, or the inventory processes, because those are the things that are really going to impact, again, those end users. And that last best practice is, again, kind of aligning around business priorities. So, in that example I just mentioned around e-commerce, if we take a look at sort of like the front page or the product page and then the checkout process, those two are really good. We want to get those users and want them to feel that the system is reliable in that first load. But we also want to make sure from a business perspective that when they run their credit card, we're able to charge them and that process completes. So maybe those are the areas where we want to focus our reliability efforts. Again, not across the entire stack and not striving for perfection or absolutes. But that also means if we're not going to strive for 100%, that we're going to have a little bit more unreliability, right? If we're not going to get to 100% reliability, that means we've left some room on the table for a bit of unreliability. And what that really means is there is an acceptable amount of errors we're willing to take on, an acceptable amount of risk we're willing to take on. And the nice thing is that the way we think about things like that in SRE is that becomes a budget that we can then allocate towards things like innovation or feature development. So for example, when you've got error budget available, let's prioritize things like velocity of new releases, right? Let's get new features out there. Let's try to do things like infrastructure changes or manage around some of the hardware downtime we need to do, or maybe try out some new, interesting, risky experiments. But when you've exhausted that error budget, when we've got no more errors left to give, that's when you really want to prioritize reliability. Slow down on feature releases, right? Prioritize the items that we found in our most recent postmortem and make sure we're addressing those things. Get to work on things like automation and automating deployment pipelines, or improving our monitoring and observability tooling. This is how we have to manage that error budget aspect. And ultimately what we're trying to do is put some structure around reliability. When we have that structure, we can also start to address the things that hurt software teams, like the ones you serve as SRE. Things like rework is just having to address the same problems over and over again because prior solutions haven't really panned out. Toil is that work that really just feels like a slog, right? It's not fun, it's not interesting, but until it's done, you are impeded from making any material progress. And burnout, well, that's really just a function of those first two, right? We know teams suffer from too much rework and too much toil, and we know that leads to burnout. So a lot of our goal around SRE, not just that reliability for end users, but it's also on giving our teams a chance to avoid burnout and work in a more productive manner. So that's a little bit of that quick background about SRE. Now I want to switch gears a little bit and talk about not just the reliability and the monitoring aspects, but what do we do with reliability information? How do we report on it? How do we make use of it and take action on it? So there are three kind of main phases when we talk about reporting reliability. The first is what's going on, and that's part of that incident status, right, if an incident occurs. And then we have to figure out what just happened, usually through a postmortem process. And then we need to make sure, and this is really, really important, we can't skip this last one, we need to regularly revisit how we're doing and how things are going. And that's through this periodic review process. So if we start with what's going on, that's where we need to have real-time incident status mechanisms and tooling in place. And for this, the tools are obviously important, but the process is even more important. We really want to have a very, very clearly documented and well-defined protocol and approach. So we want to avoid things like, hey, let's all jump on a call and try to figure out what happened. We don't want to do any of that. We want to get out of the ad hoc business and instead focus on a more process and deterministic approach to figure out what's going on, right? What do we do when that incident occurs? We want to have things like designated communications managers for internal comms and for external customer-facing communications. Even if you are an internal team and you're building internal applications and services with reliability goals, you still have a set of customers internally and externally from within your team. And we also want to have a degree of predictability around the incident management process. So we want to make sure we're committing to regular updates and that each update says when we're going to update again, right? So that users, internal or external, to our team or to our business, aren't left waiting to figure out when's the next update going to come, when are we going to find out more status. So these are the things you want to start to build as you're thinking through how we're going to manage incidents and run a reliability practice. And as you're thinking through this in that incident stage, right, the incident management stage, when we go through the real-time incident status, there are 3 phases we're going to get through, right? We're going to first detect that there was a problem. The second thing we're going to want to do is then start to mitigate that problem. And then 3, figure out what the repair is and push that repair out as quickly as possible. Now, after the incident's over, right, you've gone through detect, mitigation, and you've repaired and you've deployed the fix and things are back to normal. Then we have to get to the what just happened sort of post-mortem phase. And that's where we want to do a really good job of taking our time, not too much, not too little. We want to capture all of the data and folks' experiences around detecting, mitigating, and repairing. And we want to use that documentation to then resolve ambiguities. Was there a problem with responsibility handoff? Was there an unchecked piece of code that made it through? This is where we need to sort of identify where the process broke down in our software delivery and then start to figure out what are some of the next steps we're going to need to take in order to ensure this doesn't happen again. Now, one of the key components, and I cannot underestimate this at all, is that blamelessness is absolutely key to creating a strong reliability culture. We want to focus on identifying what caused the problem in the first place, or what contributed to that problem, but we don't want to do it in a targeted fashion where we're going and pointing our fingers at an individual or a team. We don't want to be assigning blame, right? We want to keep blame out of this completely. We simply want to be factual and understand exactly what happened. And we want to assume that everyone involved, even those that might have caused the problem, were operating with good intentions. There was no malicious intent to be had at any of these steps. Everyone was just trying to do a really good job. And ultimately, we should, acknowledge that human errors are ultimately systems problems because we're interacting with those systems. And the whole purpose of avoiding blame, right, and not having blame be part of this process and operating in a blameless manner is that it leads to a more positive culture and it avoids the negative aspects, right? If we start blaming folks willy-nilly, folks will start hiding and they'll stop sharing what's going on and they will communicate less. And so blame really often leads to hiding problems and then they don't surface until a really, really big incident happens, and that's bad for everyone involved. Now, as we're going through and we're identifying things in our postmortem, we want to have a set of next steps, right? We want to have a bunch of action items that we can take. And those action items should be prioritized, assigned, tracked, and then over time, reviewed and revisited. We want to make sure that everything we learn from that postmortem, everything that we should fix, is tracked in a backlog somewhere so that we can start knocking down those items, right? If you go back to earlier when I was talking about error budgets, if we're out of error budget, that's a good time now to start making sure, have we fixed everything on our postmortem list that we generated? Are all those tasks in our backlog, are they being prioritized and assigned and tasked and completed appropriately? When it comes to assessing the impact of an incident, we obviously need to understand, like, how bad was it really? Because we may have many systems that we're targeting with particular reliability goals, but not every single incident is equal, right? It really does depend on a bunch of additional factors. We're going to have to blend multiple data points, and we're going to have to calibrate a little bit of the expectation with stakeholders, right? What do you need to know about and why? And then we should start looking at things like the downstream dependencies, the dependencies on our services, whether it's internal or external, right? What mattered to users when that incident happened, right? What were they trying to do that they couldn't do during that time? How were they able to work around or mitigate the issue that we were having? some of the things that you can think of when you're looking at kind of a ranked list of sort of less meaningful information to more meaningful, right? Just saying that the incident happened or the issue happened, it's not really helpful. It's not much we can learn from it. But understanding maybe how long it lasted or which systems were affected by it, these start to get more meaningful, and we can start to take good action and come up with good tasks and good action items out of it. If it was impacting users to accomplish a task, that also plays into it. And, among the most meaningful pieces of data are things like it caused us to lose, X amount of revenue given that time that the system was unavailable or was slow, what have you. Once you've gotten through the incident management and the postmortem process, the next step, and this is not sort of right after, this is kind of an ongoing thing you want to do on a monthly or quarterly basis, whatever makes sense for your business, you want to have regular reviews. And this is really important because this is where kind of key directional decisions are made. And you want to, again, have these scheduled on a regular basis because you want to avoid making snap decisions based on incomplete information. Because often those snap decisions are then sort of informed or driven by kind of the emotion of the moment. And our goal is really to build a place where our teams are trusted and able to respond appropriately to individual events, and management and executives are involved in what they do on a regular basis, and they're uniquely empowered to kind of make good directional decisions after an incident has occurred. So all of this is really about building trust within the organization, and that trust pays off, right? Again, it gets us out of rework and toil over time. If teams or if management knows what happened, if we can communicate what happened based on things like the SLOs and restate some of those targets, right, we can start to show directional progress over time. So if we had an incident in month 1 and another incident in month 2, when we do that month 2 regular review, we're going to start to see that, hey, look, the items that came out of incident 1, that the action items that came out, those were not prioritized because of other business concerns. And then we had another incident in month 2. We now know that we have to go back and address those AIs if we're going to avoid having an incident in month 3. So we want to make sure we're analyzing not only the targets that we missed, but the targets that we're hitting as well, because that shows progress and it builds trust with all the teams involved. And over time, what may happen is that some of those goals, some of those SLOs, we may want to reevaluate and adjust those expectations over time and say, all right, we don't need to have, 3 nines on this service. We can settle for, 99.5% of our latency targets or of our availability goals. So that's an important aspect here as well. We want to make sure that not only are we reviewing what happened and how we're doing, but also should we be revisiting and reassessing what our goals and our objectives are. Now, part of this incident report is also, aggregating across the board because we want to be reviewing all incidents regularly and comparing with prior periods. Again, it's all about showing progress in a good way. And if there's negative progress, we want to use that as a way to drive improvement or investment into what do we need to make sure this doesn't happen again, because we're seeing a clear trend here. This is the level of reporting that we know management typically likes and gives them the power to go and, again, invest or ask for additional resources as we need. So one of the ways we can do this as well is using things like blended metrics that reflect overall impact on the business. We could also look at something called severity scope, which combines two metrics and then makes it clear that an incident might have happened, or maybe many incidents have happened, but the severity and the scope are limited. So we know it's not a huge problem to the business. We know it's something we just have to manage around and make sure that we're building for. Now, of course, we're not going to avoid sort of elephants in the room, right? High impact or high profile incidents, those things can happen. And the ones that are threatening our brand or our operations, it's likely that's what brought management or executives into this meeting that are kind of closely monitoring what's going on here. So for each of those incidents, we want to be able to communicate what happened, what, if anything, was unique about this incident, and what is being done to mitigate and make sure we don't have this again, right? You want to consider sort of the value to management there and say, we will need to assess the impact in the subjective terms as needed. So a good example of that might be like, hey, if our e-commerce site goes down on a random Tuesday in April, it's probably not terrible. But if that were to happen in something like, that 5-day window between Black Friday and Cyber Monday, that's a terrible, terrible outage because that impacts the business in a really, really significant way. So that whole concept of presenting the information around, severity and scope, that scope also includes some of that contextual information like the time of year it might have happened. Again, depending on the application, depending on the business, right? That's all we need to take into account as we're reporting on this information. Now, as we start to look ahead, we also want to use this regular reporting time to also forecast things like demand, right? Do we need to plan ahead now, knowing what we've dealt with in the past? Do we need to plan for additional capacity, maybe? Do we need to factor in for larger amounts of traffic coming through or another business goal like a big sale or something? I'm using e-commerce as an example, but because it's a really easy one to understand. But it's an important thing to take into account. Many of those things we're talking about around forecasting aren't necessarily technical. They have technical outcomes, like do we need more infrastructure? Do we need more people? But the goals themselves are outside of sort of the technical domain. And then as we're thinking again about kind of looking ahead further around demand, what is the team trying to get to? Are we trying to improve reliability or just keep it the same, right? That's another important question. And we should offer some defensibility there, right? Why do we want to keep reliability the same, or why do we need to drive that improvement, right? All of that becoming part of that periodic review is really, really important because it allows us to learn and reflect each time we review this information. Now, after all that periodic review process and all that data is captured and communicated, we need to get to that part of what requests are we making, what proposals are we going to make, and then we need to start making some decisions. And so that means, do we need to change our plans? For example, an engineering team may have a sprint planned with no postmortem AIs before that review. But after that review, they've learned that based on what the business is asking for, based on the trends around reliability, that engineering team needs to make all of their priority revolve around those action items that we discovered from the most recent postmortem. And that's really the opportunity here. It's to get everyone in the same room together and make sure everyone's clear how engineering is going to adapt and evolve their approach and how they're going to get support from management to make sure that that happens. Because if they need to get more reliability or increase things, or they need more infrastructure support, this is the right time to make those requests, make those proposals, and get decisions back from management. And then it's a question of, as part of this review, do we also need to revisit our protocols around maybe things like incident management, right? There may be an opportunity to say, hey, our process here fell over in some meaningful way or wasn't satisfactory. Let's also make improvements not only to our teams and our technology, but let's also make improvements to the process by which we handle incidents and report on them and generate the action items that come out of them. So this is all part of SRE, right? It's not just SLIs, SLOs, and SLAs. It's understanding how reliability affects our end users and how we communicate that back to the rest of the organization. Because we're really trying to get to this common language and understanding across all parts of our business if we want to improve the reliability of our software. And as you'll notice, we're not talking about a lot of specific technologies and tools because while those are important, the people and process parts are really the most important aspects of reliability, right? People are impacted when our software isn't reliable, whether it's end users or our own internal teams or our own internal engineering teams. Now, we covered a lot of ground in a really, really, really short amount of time, just like we do every month with these talks. If you want to learn more, I highly suggest you go check out the SRE book, which is at sre.google/books. There, you can get the book for free and just read through all of it and really get a clear understanding of not only the philosophy, but how to apply SRE in many ways. And there's a metric ton of detail that I was not able to cover in this video. So I highly recommend, if you're interested in this topic, go read the SRE book. It's a required reading around here because you've really got to understand reliability is not just the domain of the SRE team. It's everyone's responsibility. And as you want to dig in further and further, I can't recommend enough. Check out the cloudopssandbox.dev. It is a turnkey kind of sample environment for you to launch a microservices application, and it's all been well instrumented with all of our cloud operations tools. So things like trace, debug, monitoring, SLOs, you name it. It's all baked in there. and you get a chance to really get a sense for, all right, here's some load running against an e-commerce application. I can set SLAs. I can trace requests. I can look through the debug logs and see how things failed or are working. So you can start to build up a practice, or at least an understanding around the tools that we have. Now, again, the tools are only part of it. You'll have to bring the people in the process to this equation as well. But from a starting point, the tools in CloudOps Sandbox in particular do give you a leg up, because they also include some SRE playbooks as well that you can kind of practice around. Now, that's all we have time for this month. I look forward to seeing you all next month. Thank you so much.